Hello all, I am Dr. Praveen Chaurasia, working as an assistant professor at Department of Electronics and Communication Engineering in IMS Engineering College, Ghaziabad, which is affiliated to Dr. APJ Abdul Kalam Technical University, Lucknow. Here I will talk about in this lecture about image enhancement, need for image enhancement and its operation, right. So, let us talk about the first slide of this lecture. So, here I am just talking about the enhancement of image. So, what is basically the enhancement of image is? If you observe this image, then first image is look like that is not that much completely observable, and we can say that image is just a raw image. Okay. So, for the sake of all the information which is present by this image, which is presenting by this image, then we have to enhance this image. After this operation we can observe each and every pixel of this particular image. So, the complete information of this image we can capture. So, that is the need of image enhancement we can say about it. Okay. So, it is just an improvement of image which is suitable for specific applications. And another thing, if you observe here, then each enhancement is not having a same technique. So, it may vary as far as the applications which is present during the enhancement of this particular image. And if you see, if you have some different kind of task, then you have to choose different kind of techniques of image enhancement. So, that is the, we can say that is the basic definition of image enhancement and its process. Okay. Now, if you observe the enhanced image by using this particular example, then you can see in fog time, then your image is look like in this manner. Okay. So, this is the original image, but if you remove this type of haziness in this image, then your image will become an enhanced type. So, one of the correction which is the gamma correction we are opting here, and by which we can understand the enhanced image is look like in this way. Okay. Now, if we talk about the methods of image enhancement, then we have three basic method of image enhancement. Okay. So, first one, if we talk about in single pixel wise. So, point processing is come to the picture. So, for point processing, if we talk about, then we would have contrast enhancement, histogram modeling, image averaging. Okay. So, these three methods are belongs to the point processing. After that, spatial filtering is related to filters, okay, which is coordinate, which are varying with the coordinate. So, linear type of filters we have. Another type of filter we can say that is non-linear filters, those are not having linear property, then we can say these are the non-linear type of filter. After that, edge detection we can also observe by using derivative method. So, first that derivative, second derivative method we can also talk about. So, these kind of detection is under the spatial filtering. Okay. Last of this type of filtering, that is zooming. So, that is also one kind of spatial filtering. After that, if we talk about another method of this enhancement, then it is image coloring. Okay. So, pseudo coloring is one of the type of this method, and another one is false coloring. Okay. So, these two kind of coloring is present in an image enhancement. For the third type of method. Okay. So, let us talk about one by one. So, here I am talking about the point processing by which we can enhance the contrast. Okay. So, if we talk about to enhance the contrast, then we have to focus on the brightness as well as contrast. Okay. So, if we have a m cross n image, then the brightness can be identified using this expression, which is j equal to 1 upon m into n summation from I from 1 to m, which is actually showing the row of one particular digital image, and another summation that is j from 1 to n, and f of I comma j, where f of I comma j is nothing but that is showing the digital image function, which we have already talked about in previous lecture. Okay. Now, if we talk about the contrast, then it can be defined like C equal to square root 1 upon m into n, summation from I equal to 1 to m, and summation another summation for j from 1 to capital N. Okay. And your digital image has to be subtracted by the previous one, that is brightness, and it is nothing but it is j. Okay. So, we have to take the square also for f of I j minus j. Okay. So, by this equation you can calculate the contrast of one particular image, where you can say here then m and n are the image dimensions, and f of I comma j is a gray level value at row of I and column of j. Okay. And if we talk about the intensity transformation or gray level mapping function, then we can always focus on the brightness and contrast for this particular enhancement. Okay. So, this is the just we can say expression wise we can use, and after which if we talk about the different kind of value of this image, then you can see the brightness and contrast. Contrast is representing by C. So, if contrast is 29, then your first image is look like this one, and j is equal to 194. So, that is belongs to the first image information. If we enhance the contrast as well as lower the brightness, that is j, then j equal to 112. So, your brightness is very less as compared to previous one, as compared to first image, then second image brightness is low, and contrast we have enhanced. So, C equal to 47, it is enhanced from 29 to 47. Okay. So, your image will look like in this manner. So, variation in the brightness and contrast you can observe by using this example. Now, another method, if we talk about the point processing, then that is histogram modeling. Okay. So, histogram is nothing but it is just showing the statistical distribution of image pixel brightness, and if one image is look like in this manner, that is already enhanced image and contrast is having very high as compared to brightness, then your histogram is look like this way, and histogram is just observing, just giving the idea of how many pixels are having higher gray level. Okay. So, at where then you can observe that up to maximum more than 800 pixels are at 150 pixels are having 800. Yeah, if we can say that on the y axis number of pixels are there, and if we talk about on the x axis, that is the gray level of this particular histogram. So, if we see, then most of the pixel are having 150 pixels are having more than 800 value, 800 pixel are having more than 150 value of gray level. Okay. And gray level actually varying from 0 to 255. Okay. So, that information is actually providing by histogram. Okay. Now, if we talk about another slide of this lecture, then we would have the point processing is also called intensity transformation or gray level mapping function, and that point processing can be categorized in two ways. First one is linear function and second one is non-linear function. If we talk about the linear function, then we would have a straight line, and all the straight line is not tends to be linear one. You have to maintain the linearity which is started from the origin as well. Okay. And the straight line equation should be there. So, that is the linear intensity transformation function, and in this function we would have negative transformation and identity transformation function. Okay. Now, you can see here the negative transformation. If we talk about the negative picture of one image, then you can see here first image is just a original image and second image is generated negative image. How we can generate this negative image? Then we would have a different formula. Then S is equal to L minus 1 minus R, where S is a negative image, negative image value, okay, for each pixel, and L has a maximum gray level between 0 to 255, and R is the original gray scale image. So, by using this formula we can get the negative image of original image of any original image. Okay. Now, if we talk about another linear equation, then histogram stretching is also there. So, you can observe if we have a f kind of image, then you directly find the g kind of image, that is the totally enhanced image by using this phenomena. So, here you can observe the g of I of j is 0 when f I of j is less than f of minimum. Okay. Here we have to define the minimum and maximum value of gray level. After that, if it is varying from minimum to maximum, then its relation is different. So, g of I of j will become L minus 1 upon f maximum minus f of minimum multiply with f of I j minus f of minimum. Okay. And if f of I j is greater than f of maximum, then it has to be L minus 1. Okay. And you can also observe here that L minus 1 is also useful for to find the negative image for one particular original image. Okay. So, that L minus 1 is actually at the third condition will be satisfied here. Okay. So, that is also look like a straight line. So, that is also under the linear type of function. Now, if we talk about this particular image, then you can identify f minimum and f maximum. Okay. So, between 0 to 255 you can find the value of f minimum and f maximum. So, here if one image is there, then you can directly find the histogram, and after the histogram, after finding the histogram, then you can observe the minimum value of f and maximum value of f. So, here I am just giving the example, that is f minimum is 110 and f maximum is 225. Okay. So, image with their histogram is just showing like this way. Now, if we talk about converted image after stretching of histogram, here I am just using this formula, okay, that is the histogram stretching. Okay. So, by using this formula, then you directly find the value of this histogram, and it is distributed in a, you can say, in a very different manner, and you have completed almost all of the level. Okay. So, 0 to 255 value are having each and every pixel as well. Okay. So, 0 to 255 value can hold each and every pixel. In previous one, it has only 110 and 225. So, your histogram is actually restricted. Okay. Now, here we are stretching this histogram. Okay. So, what is the changes is occurred due to this histogram stretching? Your image is get enhanced. Okay. Your image is get enhanced by doing the histogram stretching. Now, if we talk about the gray level inversion, now here we have a f type of image and you have to get the g type of image, then gray scale inversion is look like in this manner, and we can use such type of phenomena at where that negative slope type of straight line we have to observe. Okay. So, after gray level inversion, you just see the black portion is look like a white and white portion is look like a black. Okay. So, that kind of inversion is known as gray scale inversion. Why it is so? Because in this equation if you see, then if g is high, then f is low. When f is high, then g is low. Okay. So, that kind of phenomena is just converted the gray scale inversion, right. Now, if we talk about references of this kind of information, then we would have first book, that is Rafael C. Gonzalez and Richard E. Woods, which is one of the very good book of this subject, and it is also the textbook of digital image processing, 3rd edition, Prentice Hall, which has been published on 2007. right. And Jairam book, that is also very good book, and we have taken we have taken this book as a reference one. So, that is also having a title, that is Digital Image Processing, Tata McGraw-Hill TMH publication, and published on 2009. And third one, which is actually we are using in this particular lecture. Okay. So, that actually the journal paper. So, we have taken the reference of this paper, which is congestion detection and propagation in urban areas using histogram model, because in this lecture we have covered so many histogram process. From starting one we have used histogram modeling, after that we have to have histogram stretching. So, that kind of information we have taken from the third reference, okay, and by which we can understand what is the difference is taken care of f minimum and f maximum. So, that thing we have also observed during this reference, and by which you can understand the image enhancement, what is the image enhancement it is, and how one image can enhance easily using the image histogram stretching, right. So, that is just giving the very good example. If your image is look like this way and your enhanced image is look like in this particular manner. If your histogram is enhanced, here you can directly observe, then if your histogram is look like in this manner, then stretched histogram is in a broad manner, because it is started from 0 to directly 255. So, all the pixel value you can taken into the account. After that, the another kind of inversion we can observe. So, if we have a f image and directly you can find the g image. So, black portion will become white and white portion will become black. Okay. So, that is just a gray scale inversion. And if we talk about the another method, which is we have already, we can also cover, then that is the spatial filtering. Okay. So, in next lecture we can also talk about the spatial filtering, and in those lecture we will talk about the linear filters, non-linear filters, edge detection, zooming, and we can also cover the image coloring. We will also cover this thing, that is pseudo coloring and false coloring. In this lecture we have actually focused on contrast enhancement. So, by using brightness and contrast value we can get the contrast enhanced image, and after the histogram modeling. So, histogram stretching we have observed in this particular lecture. So, by using image histogram stretching we can also understand what is the histogram modeling is actually present related to the image enhancement. And image averaging is also one kind of point processing method to enhance the image. So, that thing we will also talk about in next lecture. So, we have covered from point processing, started from contrast enhancement and histogram modeling. Next lecture we will also talk about the image averaging and spatial filtering. So, here you can see the histogram modeling, and we have also completed the linear function only, because non-linear function we can also talk about later. Okay. So, in another lecture we will talk about the non-linear function, and if we have a f kind of image, then how we can generate the g kind of image, that is the enhanced one. Okay. So, by using non-linear relation you directly identify how we can find the value of non-linear function, and how we can make the relation between the g and f with respect to the non-linear kind of functions. Okay. Here you directly identify the relation between the f and g is just a relation of straight line. So, that is under the linear function. Okay. So, now you can also generate the negative transformation using linear, and if you talk about the another histogram stretching, that is also used in an image enhancement. So, you can also observe the relation between g and f is just a straight line. So, we can say that is also a linear kind of information we can observe here. Okay. So, if we talk about the second relation of G and F, that is G I of j is equal to L minus 1 F maximum divided by F maximum minus F minimum multiply with F of I comma j minus F of minimum, right. So, here you can, if you observe, then it is just a y equal to m x plus c, okay, where y is nothing but that is g of I of j. So, y coordinate or you can say vertical coordinate is just a g, and if we talk about x coordinate or we can say horizontal coordinate, then it is f of I of j. Okay. So, it is, if you simplify, then you can directly identify that relation is related to a straight line. So, we can say that is nothing but it is a linear kind of function, and by which we can identify the point processing, and after the point processing you can observe this thing, then your original image is look like in this manner, and after the image enhancement using the histogram stretching, then it will look like in this particular enhanced version. Okay. So, your enhanced image is directly enhanced by linear function of f between the g and f. Okay. After that, Grill scale inversion is also kind of linear one, because f and g is also having a straight line relation between them. So, your black portion will become white and white portion will become black, because if you observe in this function, then where f is 0, then g is high. Here you can also observe in a equation, then if you say the f value which is the original one, original image, then if f is equal to 0, then you can observe here, then g is equal to L minus 1, and if you moving right hand side of f, then f is moving from 0 to L minus 1, then your g will become slightly decaying in nature. Okay. So, if we have f is equal to L minus 1, then g is equal to g will become 0. Okay. So, your completely inversion is take place here, okay, where you have you can say 0 value at any one particular digital image, then it will just converted into the 255, that is just showing the black portion of that particular image. So, 0 is showing the white portion, you can observe here. So, at where the completely black is there, then you can observe the completely white portion there. Okay. Here if we talk about this portion, let me consider this portion is completely black. So, here you can observe this portion is completely, it will become white portion. So, that is just a relation between that thing is just showing the inversion of gray scale. Okay. So, if we say that 0 label is nothing but it is the white label, or you can say those pixels are holding the value of 0 here. If we say this picture is holding a 0 value, then after the inversion this particular pixel is actually taken place as a high value, that is 255. Okay. So, that kind of changes you can observe there, and after the inversion you can identify that relation is actually it is just a straight line. So, that thing we have completed in this particular lecture, and we have taken care of these all references. Okay. So, histogram modeling is actually giving by the third reference. Okay. So, now another modeling, another method of image enhancement we will talk about in next lecture. Okay. Thank you.